Altair Knowledge Studio supports Autoregressive Integrated Moving Average, or ARIMA, models. They're a powerful way to make accurate predictions based on time series data. It's easy to build and use ARIMA machine learning models in Knowledge Studio. We have imported a dataset of airline passenger data and connected an ARIMA node to the dataset. To review the model node, right-click on the ARIMA node and select Modify. This window allows users to select the column containing the time index variable we wish to use and the column being forecast, passengers in our example. This ARIMA wizard has three sections: diagnostic plots, ARIMA parameters, and data partitioning. Diagnostic plots help users understand their data and decide how to configure the ARIMA model. The ARIMA parameters section is where the user builds the actual model. Note there are two sections, Auto ARIMA and User-Defined ARIMA. The data partitioning section controls how the data is used for training and validation. Let's look at diagnostic plots in more detail. The user can also decompose the data with diagnostic plots. Auto ARIMA estimates parameter values by searching across the grid, building multiple models, and selecting the best model based on an evaluation criterion. Users enter minimum and maximum values for the grid, that is, where to start and end the search. Users can also enter the values for ARIMA parameters manually to build a model. The ARIMA wizard also helps the user transform the data if required. For example, sometimes users may prefer to apply a log transform. With a single click, users can compare the transformed data with the observed data. As we can see in the data partitioning section, we have used 20% of the data to validate our model and 80% to build our model. Knowledge Studio generates Python code automatically based on user inputs. Users can copy this code to other systems and modify it as needed. At this point, users can run the model or cancel and review the results. We see three tabs: Results, Diagnostic Plots, and Forecast. The Results tab displays a summary, including the variable used for forecasting, the number of steps being forecasted, the actual model itself, and standard metrics for evaluating the model. The Diagnostic Plots tab displays the residual plot, residual autocorrelation, and a residual histogram. The Forecast tab is the actual forecast. The purple trace is the observed data, and the green trace shows the forecast.